Hello. Welcome back to Module 1, Introduction to Artificial Intelligence. Today, we will discuss Section 2, What is Artificial Intelligence? In this video, you will learn some definitions of artificial intelligence, or AI, and some of its key concepts. While definitions vary, human intelligence is typically characterized as cognitive abilities that can involve such things as reasoning, planning, abstract thinking, grasping complex ideas, problem-solving, and learning from experience. Cognition is defined by the American Psychological Association as all forms of knowing and awareness, such as perceiving, conceiving, remembering, reasoning, judging, imagining, and problem-solving. Simply put, cognition is thinking. Artificial intelligence was first defined in 1956 as the science and engineering of making intelligent machines. Nielsen defines AI as an activity devoted to making machines intelligent, and intelligence is that quality that enables an entity to function appropriately and with foresight in its environment. Schenck asserts AI depends heavily on the goals of the researchers involved, and any definition is dependent upon the methods that are being employed in building AI models. He continued that the primary goal in AI is to build an intelligent machine and to discover the nature of intelligence. According to Schenck, the features of an intelligent entity are communication, internal knowledge, world knowledge, intentionality, and creativity. He emphasized the ability to learn is the most important component of intelligence. Russell and Norvig describe intelligence in terms of acting or thinking either humanly or rationally. The Turing test, proposed by Alan Turing as the imitation game, was designed as a thought experiment to test whether a machine can think and determine how one might prove it. After posing some written questions, a human interrogator would attempt to conclude whether the written responses were derived from a person or a computer. To pass the test, the computer in question would need to be capable of natural language processing, knowledge representation, automated reasoning, and machine learning. Natural language processing is a technique that enables computer to mine and interpret verbal communication, based on matching words and sentences to vast language databases, closely replicating some of the interactional patterns in human communication. Knowledge representation is concerned with designing agents that recognize the external world, focus on the necessary aspects, and represents the information in a form that allows the agent to make good decisions. Automated reasoning is the ability of a computer to apply prior experiences and knowledge, answer questions, and draw new conclusions. Machine learning will be covered in detail in a later section. Once developed, a precise theory of the mind can be expressed as a computer program. If the program's input and output behaviors match that of human beings, the results may be evidence that the program is operating in a similar fashion to humans. As we discussed in Module 6 of the Basic Information Literacy series, the Greek philosopher Aristotle attempted to codify rational thinking. His syllogisms provided patterns for argument structures that consistently yielded correct conclusions when given correct premises. Rational action can be realized through the same skills as those needed for the Turing test. Knowledge representation and automated reasoning allow a computer program to reach good decisions. In order to be intelligent, a machine would have to demonstrate human actions and thinking, and rational actions and thinking. Goel and Davies depict AI as the coming together of cognitive systems, robotics, and machine learning. These three areas of AI, which we will discuss in greater detail in Module 2, have produced narrow AI, or weak AI. Weak AI is AI that is intelligent within a specific field and limited to specific functions. This is a simulation of intelligence, without any real comprehension or cognition. General AI, or strong AI, is a self-aware computer system that matches or surpasses human intelligence across multiple fields, a breakthrough that has not yet been achieved. The 5 big ideas were developed by the AI for K-12 initiative, a project funded by the National Science Foundation. The first idea is perception, in which computers perceive the world using sensors. AI can see and hear by extracting information from sensory signals. The amount of domain knowledge needed to comprehend visual images and a spoken language formed by vocabulary, grammar, and usage patterns is immense. An image dataset is a collection of digital images that have been curated for testing, training, and evaluating the performance of machine learning and AI algorithms, also known as computer vision algorithms. For example, VGGFace 2 published by the University of Oxford, is a research dataset of over 3.3 million facial images that offer a multitude of poses, ages, illuminations, ethnicities, and professions. If this kind of processed information is lacking in computer vision or a voice-based agent, then object or speech recognition cannot come close to human-level accuracy. If you like, pause the video, scan the QR code, and take a look. The second idea is representation and reasoning, where AI systems, or intelligent agents, maintain models or representations of the physical world and apply them for reasoning. Agents perceive the world through sensors, construct representations with training data that can be manipulated by applying reasoning algorithms, and generate outputs that affect society. Representation is a fundamental quandary of intelligence, either natural or artificial. While AI agents can reason about extremely complex issues, their processes are not the same as those of humans. Many types of reasoning that humans find natural still remain out of a machine's reach. The third is learning, where computers gain domain knowledge from data. Algorithms allow computers to construct their representations through data that has been inputted by humans or is perceived by the agents themselves. Again, vast amounts of data are required. The fourth is natural interaction. Making agents interact comfortably with humans is a substantial challenge for AI developers. Intelligent agents have difficulty understanding humans, including conversations in natural language, recognizing emotions, and inferring intentions from observed behavior. While computers can understand natural language to a certain extent, they lack the basic elements of general reasoning and conversational capabilities. Generative AI cannot grasp basic facts of the world that are not made explicit in words. Graceful interactions between humans and agents is becoming increasingly important as they share living and working spaces. The last idea is societal impact. AI applications can influence society in positive and negative ways. AI has been connected to other capacities including STEM and STEAM education, workforce development, and such industries as art, business, and science. You should be able to recognize how AI will impact your life. You can ask yourself, what AI applications should be used? What ethical criteria is being used for AI? Automation may lead to unprecedented changes in the labor market or considerable unemployment. Geoffrey Hinton, the father of AI, and the 2024 Nobel Prize winner in physics, left his position at Google over these very reasons. A McKinsey Global Institute report estimated that approximately 30% of working hours globally could be automated by 2030, with up to 44% of U.S. jobs being at similar risk. AI may enable increased government surveillance and a degradation of privacy rights. While utilizing AI's benefits, great care should be taken in the areas of transparency and fairness. Next time. In the next video, we'll move on to Module 2, Artificial Intelligence Awareness, and talk about the impact AI has made on modern society and how you can understand this complicated branch of science. Until then, thank you for your time. If you want to learn more about the subjects we have discussed, these are the sources used for this section.